knowledge makes you great.
It's been 25 years of passionate chasing. Go ahead. Hello everyone, welcome to yet another episode of Hamara Tejas. This is the 8th episode and this is coming to you from Center for Airborne Systems, CABS, a very high profile, less talked about lab of DRDO. Along with me today is my co-anchor, now popular co-anchor, Dr. Kota Harinarayana, and 3 other eminent scientists from different fields. Dr. Purushottam, on to my left, scientist and project director of Lightning Test Facility at CABS. Next to Dr. Kota is Shiny Thomas, Group Director, Electrical Systems of ADA, and Professor Uday Kumar, who is the Chairman of Electrical Department of Indian Institute of Science, IISc. We told you, Hamara Tejas is spreading. Hamara Tejas, new people are coming into it. And this is a classic example of what is in store. You will see more and more superheroes from India's aerospace defense science joining this program. Why we are here today is a very significant thing. This is the Lightning Test Facility, one of its kind created for the Tejas program. So we are sitting in a huge hangar of CABS, and I am actually overlooking the HAL runway. This outside is the runway. This episode, we are going to focus on the role of academia in propelling the Tejas program, because that's less talked about. IISc has done phenomenal work over the years supporting this program, but always remained as an unsung hero. Likewise, many academic institutions. Dr. Kota will speak about it. So let me first welcome all our guests to this show. Thank you so much for taking your time out. And thank you, Sir CABS. I must thank the team CABS for all that you have organized here. Straight away to Dr. Kota Harinarayana, Academia and Tejas program.
I think one of the most significant achievements of light combat aircraft program is to bring the strength of academic institution to the success of the LCA program. Okay, we are here sitting here in the lightning test facility. I thought symbolically also this represents the contribution, direct contribution of academic institution, a premier academic institution in the country, that is Indian Institute of Science. Okay, Professor Uday Kumar, I would like you to bring to the benefit of our people who are watching this, that what is it that we have done whereby the aircraft, which is all composite aircraft, we made it safe, made it very thing, and it's not only design, but also you built a facility where the design could be validated. Okay, I want you to tell a few things about that, then we will move forward.
Thank you, Dr. Kota Harinarayana. Academia has multiple responsibilities in my opinion, and one of them is to interact closely with the PSUs, defense organizations, for two reasons. One is we are paid by the taxpayers of the country, so we need to pay back something directly, while we educate people, train people is the second one. Also, fundamentals what we study and try to master will not be complete unless you dwell into practical system. That has its own beauty and complexity. So, this example what you are quoting is a very unique opportunity for Department of High Voltage Engineering that time. Now, it is a part of electrical engineering, where we could build a impulse voltage generator of this level for the first time in our country. We have trusted the institute, and institute could deliver it. Maybe there could be some delays because of the fabrication and other issues, but it was delivered and made operational for testing of components as well as testing of electronic systems.
I think at this time I am remembering Professor Nagabhushana, who led the team, who really put his heart and soul into it. Okay, and in fact he became a symbol of this collaborative venture. And I would like Saini to see how what we have done and what we are taking forward. Okay.
So, sir, the initial days of program, the important thing what we have done was to make sure that the design is for the all-weather aircraft. So, for validating those design, particularly the structural design, we have used this lightning facility we have established through Indian Institute of Science. So, we have tested all the major components of LCA, and the entire design of LCA has been validated with various tests, and multiple teams have handled this project. Many earlier senior scientists were handled. Today, we have completed the production with the verification and validation of these tests. Now, further, we have not stopped with the basic test and basic understanding of the phenomena of lightning. What we are doing currently is, we are understanding more, or more advanced studies we are doing. So, in this process we have sanctioned some projects further to Indian Institute of Science. So, the impact of lightning on the aircraft and what is the indirect impact on the internal equipments and the cables and the pipelines and the LRUs. Is the design is anything further we wanted to optimize, further test, optimize for the future program. So, currently LCA Mark II and AMCA, we are going to use this validation of these tests. So, our aircraft is here. So, we will be doing the entire aircraft level test and validate the tool which is developed by Indian Institute of Science. The most important thing is that, sir, these kind of tools are used internationally. But since this is our own project, we wanted to do an indigenized tool so that our data will be within our country, and we have used the Indian Institute of Science for this activity.
Good. I thought we are taking it forward. Dr. Purushottam, while it was established for the light combat aircraft, my understanding is you are not stopped with light combat aircraft. No, would you like to say what further, what all the ways and what all the aircraft, what all other programs we got benefited by this facility?
After getting activated in the year 1992, thanks to the vision of you and Dr. G.R. Nagabhushana, Professor G.R. Nagabhushana, the LTF facility has become a reality for the first time in India, wherein under one house, in those days also, we have the direct lightning and indirect lightning, both were established for the first time in the country. And apart from LCS testing, we did the testing for Hamsa aircraft, Saras aircraft, and LUH was now getting tested. In the past, we did for testing for ALH helicopter also. The Astra missile, which is now getting integrated into the Indian Air Force services, is tested here. And we did the testing for AWS aircraft here. And we did the testing for the UAVs programs of AD, DRDO. We have opened this LTF facility for so much of Indian industry, wherein earlier I was told by the industry that they need to go to China or other European countries for the lightning test facility. But now they know that there is a facility called lightning test facility, wherein they are specifically looking for the high current testing facility, HCG test facility, that is available only in India, only in CABS. And they are coming here for that because the industry is open. And not only doing testing, we are able to give some design guidelines, design aid to them, with which they are able to come with their iterative process and then come back and then product validation they are able to do.
First, I'll ask you about the challenges you guys faced in setting up such a national facility. You could perhaps then talk about what is a lightning test facility for a young fellow listening to this. And then, yes, and any of you could also talk about what are the unique features when you say direct lighting, indirect lighting, what are the things explained. Dr. Kota could perhaps speak about when a Tejas flies or when a fighter flies, what does the pilot knows while flying that he is hit by a lightning? What happens with the internal systems from the school, college point of view? Eventually, Hamara Tejas program is only for them. This is not for experts. Starting with you, sir.
The challenges were many, because there is no industry who had any experience of building a component. So then the Institute of Science and the leadership of Dr. Nagabhushana has to identify important element of the generator, that is a capacitor. The capacitor is a kind of a simple word to say because it is an impulse capacitor. Its design will involve mechanical, part of hydrodynamics, then comes electrical. It's a very complicated system. Most of the capacitor, I think, use castor oil as an insulation and quality of the oil because it is not one time you have to use, you have to for a lifetime of 20-25 years. So that was slowly overcome by collaborating with those industries, exchanging knowledges because they had their expertise, institute had their expertise. Finally, they were built. Afterwards, we had problems which are localized as well as some kind of, because fabrication, as you know, when you order for something, it never gets.
So this is a completely 100% Desi system?
100% Desi system.
100%. And here when we are talking about currents, high voltage and current, it is not in hundreds and thousands. For a very, very small time, very micro time, they are going to million amperes. That is the level of what you call current that comes when a lightning for a very, very short time. But that is what you are what you call creating here. Okay? And today, because the whole aircraft has been tested, validated and all, the pilot flies with total confidence. He is not worried because all that has been actually simulated. Whole aircraft is working. All equipment are on. Then the test is done. So they know equipment will not fail. Okay? It is the intensity of testing that we have done that gives the confidence not only to pilot, it also gives the reliabilities of the aircraft by orders of magnitude. Okay?
So a lightning strike varies, right?
So to add to what Dr. Kota sir said just now, the amount of voltage that is generated here goes up to 4 million volts. Generally, for a regular power point plug in our homes, we look at 230 volts. I am talking about 4 million volts of voltage that is generated here, and for which the capacitors, as it was told by Dr. Professor Uday Kumar, they are specially designed by a identified manufacturer who is in Gujarat, and the capacitors are designed indigenously.
What is the company's name?
Asia capacity.
Yeah, of course, because it's a matter of pride for
it
us
is
Indian
important
company.
that our industry has supported us.
Maybe if you convert into lakhs, people will understand it better. Million is not used in day to day. 1 million is 10 lakhs. So 40 lakhs.
40 lakh volts.
Volts is what is
40 lakh volts.
So what is the, just a very, very basic question. So when it comes to a lightning strike, it varies, right, the range?
Voltage we cannot define voltage as it is, but the cloud potential can reach 300 million volts or more. If you want to convert into crores, some 30, 40, 50, 100 crores if you want. But that is cloud. What you see within the small aircraft will be a few million.
So just a very, in the military program world over, did the pilots experience lightning strike and eventually they had issues?
As the statistics says that every aircraft will experience close to about 40 to 50 lightning strikes in a year. This is what the statistics say.
It's not an unusual thing.
It's not unusual. If you look at some of the videos available in the open literature, lightning strikes totally damage the aircraft, and then the total aircraft is totally made into pieces.
So means the civil aircraft is prone to more such attacks.
Yeah, but they are mostly metallic in their construction up till.
Metallic aircraft, it is a good conductor, but we are made out of composite. Composite is not a good conductor. So you have to bring in new design, not only design new, but also a test facility to test that the design is okay. That is both were done here. And when this facility became operational, Professor Nagbhushan was to tell me, this perhaps the only facility where both high current, high voltage is under one roof. Exactly. Not even UK and all those countries, it is not available. Okay, that is the speciality of this facility.
To add to what sir was mentioning, I mentioned some time ago about the high voltage, impulse voltage, wherein we are generating about 40 lakhs of voltage, 40 lakh voltage of power. Now, high current, what Dr. Kota sir mentioned, high current we are going to generate it in 4 waveforms. That high current value is 200 kiloamperes. So when you switch on a fan, we consume about 0.25 amps, where I am talking about 200,000 of current, and that is coming in a fraction of a second. So without knowing that the damage happened already. By the time you notice that lightning has happened, damage has already occurred and then it has already smashed. So that is the effect to be studied compulsorily on any aircraft system, particularly an aircraft which is in the air. We are going to leave the pilot and the machinery to the nature god. And at that time, until we are 100% sure about the safety incorporated in the design, we can't allow that to happen. That safety in terms of nature's capacity is proved here for LCA, and apart from LCA, it is done also for other aircraft.
So Shiny Thomas, I want to just come to you, ma'am. When you sit here, when you listen to all these grades, I'm sure you have a lot of experience being part of this facility, right? How long now with this facility from ADA?
From ADA now this is the 8th year. Basically I was involved from the radome test that is done in late 90s from HAL. So I have witnessed the test and I have participated from electrical system and all the tests we have participated, wing we have done and multiple panels for the designs we have done. I was only a participant. There are other teams who are doing from ADA the test.
All right, so if a youngster asks you, not Anantha Krishnan, a 8th standard or 10th standard student, what are the safety features as a scientist you should take while dealing with such high power to generate lightning?
Maybe
Professor
Uday.
There are many issues there. First issue is safety by direct passage of induced current, not direct current. You are not supposed to be in the area where testing is done. That's the reason fence is arranged there. So fence is the first one. So test area where high fields are there, where you are susceptible, nobody is allowed. Secondly, there are induced things here and around. Without your notice, many currents will pass through, induced current will pass through. Like your mobile receiving signal from the tower, when something happens, discharge happens, we induce current, lot more induced current. So that's the reason we have taken special precaution in the high voltage laboratory, use of cables, trenches, protection, so on and so forth. Only thing what we normally don't worry so much is the illuminated electromagnetic wave on you, but that is that happens in nature.
But I remember sometime, long time back, when I was there, I think there were some incidents, that caused some concern. I think all that is ironed out. We're not talking about that. Since Shiny Thomas ma'am is sitting quiet for a long time, what is that you want to tell tomorrow's Tessie Thomas, tomorrow's Shiny Thomas, tomorrow's, scientists who want to join HAL, DRDO, all that? What are the key
research and development?
research and development.
Generally, research.
Yeah, research and development, and also the fellows who want to get into technology research. An area, because that will eventually, because the kind of programs Dr. Kota and others have already envisioned, and now people are propelling. I saw already in Mark 1A so many things, Mark 2. So what is that you want to tell them?
Basically, I want to encourage the students who are studying high school or engineering, where is the application of their physics, chemistry, mathematics, because my own younger son used to ask, what is the use of studying all these things, where is the application of chemistry? So this is one industry, aerospace is one area where all the branches of engineering has a role to play, including architecture, how we pack the aircraft, how we keep the equipment, how optimize this small space into so much of systems built. Then even electrical high voltage area where we are discussing today, the lightning. So we have application and we have area for them to apply their minds. So my request is to whichever area what they are studying, go a little in depth and look for the application, particularly aerospace, where there are a lot of promising end applications are there. In fact, whatever I have studied in my 4 years of electrical engineering, I have fully utilized for LCA. More than that, I have learned also.
So I want to just straight away come to you, sir. The role of academia, that's today's topic. Do you think that we are actually doing justice? Everybody talks about the role of academia. What are the things you would want to now see? Increased role. How can we give increased role? Not just IIScs and IITs. Beyond that, schools, colleges, the village fellows who are very, very, very talented. Village schools, engineering colleges. So, because, Dr. Kalam always used to say the might of cities should also spread to villages. So, sir, what is that you think that academia needs to?
Let me put to you. Earlier, the questions were there. What is the role of academia? What is the thing? Industry is not getting benefited by that. I think concrete example of that is the LCA program. Outstanding test facilities, not only lightning, it is only an example there. We have established perhaps one of the finest composites technology in the world. When LCA, what you call composite wing was made, there was a team from New York which came here to see what are the hotspots in India in technology, okay? And they saw what we have done in terms of software, which could, from conceptual stage to final manufacturing and quality control, we developed the total software for that. And that is the software which was bought by Airbus, Boeing and all those people. And they've seen that we have utilized that design software. It's not a routine software, it's a design software. And using that, we made the complete wing, other parts and everything. And they were amazed, and they said that year they considered the team here as one of the 5 hotspots of the whole world.
All right.
Okay, that was the thing. And when you have a composite part, unlike a metal part, it is non-uniform. That's the problem with composites. But still, you should be able to see, even though it is non-uniform, is the design adequate or not. So you need a non-destructive testing to say it is safe or not. The whole technology of non-destructive testing, one of the professors from Aerospace Department of Institute of Science, plus from IIT Bombay, all of them have done the job. And today that is the technology we are using on the aircraft. There is a third thing. There is a technology, there is a very exciting area called computational fluid dynamics. When we started the project, we had zero knowledge, okay? Even the Europe and all were doing very rudimentary kind of things, what you call very empirical way of designing aircraft, nothing more than that. But IIT Kharagpur, IIT Bombay, Indian Institute of Science, and IIT Madras, IIT Guwahati, and there are many other things they participated. And today we have an exciting array of software which can simulate the total aircraft, simulate the weapons. It will also simulate the interference between the aircraft and there. As a result, what happened? We will be able to tell accurately how the weapons, when you drop, okay, when you launch a weapon, how it is going to behave. It is an extraordinary technology. It came totally through the academic institution. I want to add one more thing to you. When we started, we were using NC manufacturing and all. Everybody thought it is only industry we can do. You will be amazed to know the best NC is required for making aircraft models for testing in a wind tunnel. Do you know who has done that one? It is the engineering college in Coimbatore. Okay? That is the engineering college who had such good capability. They made such accurate model and they continue to develop CAD designs and all that. They become an integral part of LCA program. There is a Jadavpur University there, you know, Calcutta. I want you to hear this fellow because there was a Professor Ghosal. Okay? In fact, he was the man who validated the control law developed by a national control law team.
Okay.
And we made an autoclave. It was not behaving well. There was a lot of uneven temperature and all that. It was not usable. He came here, he spent 1 week, he cleaned up the whole thing. And then for last 20 years it is working. What I am saying is, the depth of knowledge that a professor or a small group has, that is the depth that is needed when you want to solve a problem.
Interesting. I want to just cut across to you and ask you then, are you happy with the kind of knowledge levels, expertise in today's engineering colleges? You know, because I have a fellow at home, leave alone that. I go to colleges to talk. Honestly, very shocking because, you know, so there is a problem. And if you run away from the problem and call a problem and trying to find solutions collectively, a national vision is needed to up the standards of engineering level because everything is so programmed. 6-semester project, that semester project. So what I'm saying, what is that IISc? Because IISc is linked with so many colleges, a lot of youngsters look up to that. What is it, professor, you want to see? Because it's academia, because tomorrow's projects of India need young brains, talent. Is there any problem there?
It's a very difficult question because answer is very demoting, not motivating, demotivating. Today, whether it is engineering college or even a science college, people lack fundamentals. Either the professor or the teacher, nor the students.
It is a fact, you know, we have to call a spade a spade. When it comes to education, you can't, but I can.
Yeah, but at least, yeah, but I should be very humble in that. That is a fundamental problem. If you come to engineering, the students think that's a number. You cannot simply add or subtract 0 from a big number because it's an engineering design, a practical system. They don't realize it at all. And slowly colleges are moving towards the degree or the curriculum which will fetch them the job. That way, whether civil or electrical, finally they take more courses suitable for the job. So I'm as an old timer, I'm pretty old now. I feel that core engineering is killed by IT industry. And IT industry my very close relatives, friends are working there. I know what level of technology or this was. I should not comment on that, but what goes there.
That is a cause of worry, level of engineering, level of science, basic science in school. We have overshot time. But again, I want to just come back to you before I sign off back to the lightning test facility. What is that you're going to show us today? Apparently there is a test lined up. So what is that?
We will demonstrate the high current testing on a dummy sample, which will give the period for which it will happen is microsecond duration. You can't even think by the time it would have happened. That demonstration will give for high current testing.
We will show you a very high current performance. Just keep watching. We are going to sign off. I forgot to ask you one very important question. We talked about IISc's role. Quickly, can you tell us what are the other academic institutions in India that played a key role in LC program?
At least for our composite design software, some 6 institutions, not all are IITs, and they have participated. And it was judged the best software in the whole world. Okay, we continue to use that software for design. Not only we use, it is used by Airbus and many other industries. And when you fly in an Airbus aircraft, some of the composite parts were designed by our software. Okay. The computational fluid dynamics software is also done by us. And we have something called what you call health monitoring, structural health monitoring, what we do. It predicts
the HMS, the health monitoring system.
Health
monitoring. Even NL, yeah.
What it does is, it continuously monitors how the aircraft or components and all are functioning. Based on that input, it will tell you that it has another 100 hours of service before it will fail. Benefit is, you don't have to remove the part prematurely, or you don't wait until part fails. Both are bad. If you remove prematurely, you are wasting your thing and you are increasing the cost of operation. If you are waiting for it to fail, the aircraft will be grounded for a long time. For a fighter to be grounded, it means it's not available to fight a war. Okay, both are bad. Okay, and this is the fellow which is helping you to tell you, continue to fly, continue to operate. We will tell you when it is going to fly, and we will give you enough time to ground the aircraft, repair it, and take it back. It's an extraordinary technology which we are bringing in now, and it has come in a very small way in LCA Mark 1, it will come in a bigger way in LCA Mark 2, and it will come much bigger way in AMCA and all that kind of a thing. It is a role of academia is very important in that kind of a thing what we are talking. All the inspection equipment we use and all, lot of them have been developed by, they are passed on to a smaller medium scale industry, and then it is now being regularly produced and all that kind. So what I am mentioning to is, we are able to demonstrate clearly to the community. Here is a concrete example how bringing together academia, R&D and industry, there is an extraordinary benefit to not only the project, but to the industries at a large.
Absolutely hear from the man who knows it all. We have to wind up this show. Before that, let's go and watch that demonstration at CABS. What a fascinating, what an unbelievable sight it was. I hope all of you enjoyed that. Time to wrap up this show, and today's Tejas fan, his name is Daniel. He is an aeroplane maker, model. He goes to schools and colleges, teaches aero modeling stuff. And we found his story very interesting, so we called him to the show. So here is what Danny has to ask Dr. Kota Harinarayana.
Hello, sir. I am someone who has grown up reading about your stories. I am so happy and proud to be sitting in front of you today. So I have a question for you, and that is, what would happen to aircrafts which are built today and after 50 years or even more than that? So what are the problems that they could come across, and what are the steps that engineers or scientists take to overcome those kind of problems?
One of the challenges is how to design for a extended period of operation. Okay, so we do number of things. One is you do study what you call an aircraft. We watch very carefully, okay, and we analyze every little problem that is coming. A lead aircraft we do, and see how the wear and tear is occurring, how damages are occurring, because it is an environment is there. Damages either to temperature or pressure variations or lightning or all that kind of a thing. We watch that, and then we try to understand what is the damage that occurs because of these things, and how far the aircraft can be safely used, okay, without any impairing either the aircraft mission for a fighter and aircraft safety. This is what we do. But nowadays, we don't have to do a lead aircraft business and all. We do what you call modeling the aircraft, that is the components, the airframe and all that. And by modeling, we not only model how it functions when it is in good shape, but also when damage occurs, how does the aircraft, and that damaged aircraft or a wear and tear that occurs or a slow fatigue damage that occurs, we model that and we try to predict what will its impact on its performance, on its safety. And taking certain factors of safety, then we will say how much the aircraft can be used. By doing that, what we have done now, earlier after about 20 years or so, they will say aircraft cannot be used or the equipment has to be thrown away, all that was happening. But now we say no, we will be able to tell you that how far you can use it safely, reliably, right? And when it has to be either replaced or overhauled. That is the new technology that has come, and I feel with this technology, the extension to which you can use the aircraft can be much more than what was done earlier. Here is a cap, keep it with yourself.
That was it all we had from this 8th edition of Hamara Tejas. I hope all of you enjoyed this very, very interesting discussion. Keep writing to us.
I have only one point to add here, a small advice to the student community. Study the subject for a passion to understand the nature, implement that in your life than studying the subject for money making. Money making automatically follow. If you study the passion with a passion to understand the nature, implement that what you learn in your real life. Money follows.
They are not chase money. So invest in your passion. What he's saying, what I keep telling all the young fellows, absolutely invest in your madness. India needs more mad people. तिरंगा की ताकत तभी आएगा देश में ज़्यादा mad लोग आएगा. Thank you so much. Stay safe, stay inspired. Wherever you can help the needy, please do that. And tricolor always pin to the heart. Thank you. Jai Hind.